Welcome to Chapter 8, where we're going to be dealing quite a bit with terms that have exponents in them. And in our first section, we're going to be looking at properties that involve products. So for example, let's say that we look at the product 7 squared times 7 cubed. Well, you can rewrite that. 7 squared is 7 times 7. 7 cubed, of course, is 7 times 7 times 7. Or we can put that all together and say that we're multiplying 5 sevens together and call it 7 to the 5th. Okay, you can do the same thing when you have a variable for a base. So notice x is the base here in both the first and second terms. So we can rewrite the first term as x times x, the second term as x times x times x. We're multiplying 5 x's together, so we can simplify that and write it as x to the 5th. And of course, you might have already spotted that we have a shortcut here. Notice that when you have the same base and you're multiplying one base times another term that has the same base, we can simply add the exponents. 2 plus 3 gives us 5. And we have a name for this. This is called the product of powers property. So we're multiplying terms that have powers or exponents, and they have to have the same base for this to work. So we have, in general, in generic terms, or algebraically, we have x to the mth times x to the nth is equal to x to the m plus n power. So add the exponents when you have the same base. Now, if you have coefficients other than 1, which will be very common, we can deal with the coefficients separately. So notice when you have 4x squared times 2x to the 7th, this is really 4 times x cubed times 2 times x to the 7th, but we can multiply in any order that we want. So if we want to deal with our coefficients first, we have 4 times 2 out front, and then deal with x to the 3rd times x to the 7th, which is x to the, add the powers together, 3 plus 7, and we get 8 times x to the 10th. So now what if we have a term that already has an exponent, and then we raise that power to another power? So here we have x squared all to the 3rd power, and we can rewrite that since it's a power of 3 on the outside. This is x squared times x squared times x squared, and we can use the rule that we just looked at and add the exponents. 2 plus 2 plus 2 will give us x to the 6th. Then notice that once again there's a shortcut here, and this one is known as the power of a power property. So we have a term with a power, or we have a power within parentheses that we raise to another power. We can simply multiply the two powers together. So if we have x to the mth raised to the nth power, we can simply multiply m times n, and that will be our exponent. And again, if you're dealing with coefficients other than 1, you can work with those coefficients separately. So if we have 2x cubed all to the 4th power, we can look at that coefficient first. That 2 needs to be raised to the 4th power. Then the x cubed also needs to be raised to the 4th power, and we can do that by multiplying our powers. 3 times 4, we end up with 2 to the 4th is 16, and then we get x to the 12th power. So let's look at some examples, and notice the directions. Simplify the expression, and write your answer using exponents. So in our first case, we have 3 times 3 to the 3rd power. So our base is 3, and we can add exponents. Notice, remember that we have 1 here in the first term. 3 is equal to 3 to the 1st power, and then we add the exponent from the second term, and we end up with 3 to the 4th. So we were asked to write our answers using exponents, so we go ahead and leave that as 3 to the 4th. In number 2, we have -4 for a base, and we want to put that in parentheses because that negative is part of the term. That's also going to be raised to the power here of 3 plus 2, and so we end up with -4 in parentheses to the 5th power. And while we're looking at this, notice that if you were to look at -4 to the 1st power, this is equal to -4. What if you look at -4 in parentheses squared though? Well, this is equal to -4 times -4, which is a positive 16. Now if you look at negative 4 cubed, this would be negative 4 times negative 4, which is 16, times negative 4 again, which is negative 64. And then if we looked at negative 4 to the fourth power, we end up with negative times negative times negative times negative, so negative times a negative is a positive, times a negative again, like we had here, is a negative, times a negative again is a positive, we would get a positive 256. So notice that, whoops, when we have an odd exponent applied to a negative number, we get a negative result. Odd exponent gives us a negative result, as opposed to when we have an even exponent, we get a positive result. Even exponent gives us a positive result. Okay, and this is why we want to make sure that we keep that negative inside the parentheses when it's supposed to be there, so that we end up with the correct sign when it's all said and done. Okay, let's look at some more examples. So in number 3, we have 3x times negative x to the fourth power. So first let's deal with our coefficients. We have 3 and negative 1 times, and now look at our exponents, x to the first plus 4. So 3 times negative 1 will give us negative 3, and then we have x to the fifth power. Alright, number 4, we have 3x squared y to the fourth z cubed times 4zx cubed. So here we have coefficients to deal with. So first of all, we have 3 times 4. Now notice we have 3 variables here. That's okay. Now it's convention to typically write these in alphabetical order. So if we look at our x terms first, we have 2 of them here and 3 of them in the second term. So x to the 2 plus 3 power. And then we look at y, which only shows up in the first term, so it's still going to be y to the fourth. And then we have z, which shows up 3 times in the first term and 1 more time in the second. So z to the 3 plus 1 power. And this will give us 3 times 4 is 12, x to the fifth, y to the fourth, z to the fourth. So now it's all one nice compact term. Number 5, here we're multiplying 3 terms together. Work with the coefficients first, so we have 3 times 3 times negative 3. And now look at our variables, and again we typically put these in alphabetical order. So we have h, which shows up twice in the first term, once in the second term, and twice in our third term. Then we have j, which shows up once in the first term, 3 times in the second term, and 4 times in the third term. And then finally k, which shows up twice in the first term. We have 2 more in the second term and 2 more in the third term. Now we can rewrite this in a more compact form. 3 times 3 is 9, times negative 3 is negative 27. And then we have h to the fifth power, j to the 8th power, k to the 6th power. Alright, number 6. We have negative 3p q cubed r cubed all raised to the third power. So deal with our coefficient first. That will give us negative 3, remember in parentheses, has to be cubed. And now we deal with the power of power property. So we have, first our exponent is 1, but we're going to cube that, so we multiply that exponent by 3. Then we have q to the 3 times 3 power, and r also to the 3 times 3 power. So when we take negative 3 times negative 3, we get a positive 9, times negative 3 again is negative 27, and then p cubed, that's a 3, q to the 9th power, r to the 9th power. All right, let's look at one more. Number 7, we have 2x to the 4th times, in parentheses, 2x to the 4th y squared, all to the 3rd power. So we need to apply this exponent first before we can multiply by that first term of 2x to the 4th. So initially I'm going to rewrite that first term as it appears. Now we need to take 2 to the 3rd power and then apply our power of power property here. So we have x to the 4 times 3 power, and then y to the 2 times 3 power. So we can rewrite this as 2x to the 4th times 2 cubed is 2 times 2 is 4 times 2 again is 8. And now we have x to the 12th power, y to the 6th power. Okay, now we can deal with our coefficients. We have 2 times 8 will be our leading coefficient. And then we have x shows up 4 times and then 12 more times. So we add those because now we're multiplying two terms that have the same base there. And then y to the 6th because it doesn't show up in the first term. And finally we get 2 times 8 is 16, x to the 16th power, y to the 6th. Okay, so now you're going to have opportunities to get lots of practice with this. Good luck and enjoy.